The Pythagorean Theorem. Proof number 19, proved by Mark Wong and Jordan Jacinto. So, what is the Pythagorean Theorem? The Pythagorean Theorem is a theory for right-angled triangles. It is also a theory made by the famous mathematician named Pythagoras. It basically shows us that a squared plus b squared equals c squared, wherein c is the longest side of the triangle, also known as the hypotenuse. This is an example. So we have sides 9 and 15 and letter B. 15 is the hypotenuse. So we want to find letter B using the equation a squared plus b squared equals c squared. So substitute the letters, you'll be able to have 9 squared plus b squared equals 15 squared. So that's going to be 81 plus b squared equals 225. What you want to do next is look for b squared. This can be achieved through subtracting 81 from 225. And that would result to 144 equals b squared. But we shouldn't stop there yet. We have to look for the square root of 144 to get side b itself. So that would be b equals 12, which is side b. Proofs about the Pythagorean theorem. There are many and countless proofs available online and in the internet. They range from simple ones to complicating ones. This is an example of a simple proof. So we have a right angle triangle with sides 4, 5, and 3. Shows areas of 4 and 3 are equal to the area of 5. This would mean that 16 plus 9 equals 25. And this basically uses the equation a squared plus b squared equals 5 squared. So this is our theory. We have our right angle triangle here with sides A, B, and C. It tells us to add a similar right triangle beside the original one. So let's add an artificial triangle there, and adding an artificial triangle would result to having a new side, which is side D. So states that the area of BAC, which is the original triangle, plus BAD, which is the artificial triangle that we've added, would equal to area of DBC, which is the overall triangle with the artificial one plus the original one. It also tells us how to get sides AD and DB. So this gives us the equations of getting sides AD and DB. So yeah. This is how to solve our theory. So let's have that previous triangle, and first we have to get side AD and BD. This is how you get them. To get side AD, you need to follow the equation AD equals AB squared divided by AC. So let's substitute the sides there. That would be AD equals 9 squared divided by 12, and that's AD equals 81 divided by 12. 81 divided by 12 is 6.75. Thus, side AD is 6.75. Next, what we want to find next would be side BD. The equation for side BD is BD equals AB times BC times AC divided by AC. So BD, substitute them. BD equals 9 times 15 divided by 12, 135 divided by 12, and side BD is 11.25. So the sides are there. What we want to do next is solve for the areas of the small and the bigger triangle to be equal to the overall triangle's area. This can be achieved. So overall triangle's area would be 12 plus 6.75. We have to add 12 plus 6.75 to get the overall base of the triangle DBC. How to get the base of the triangle? It's basically base times height divided by 2. So that's 18.75 times 9 divided by 2, which is equal to 84.375, which is the area of triangle DBC. Next, we have to find the area of the smaller triangle, which is triangle BDA. So that's 9 times 6.75 divided by 2 equals 30.375. Next, the area of the bigger triangle, which is triangle ABC, or the original triangle that we had in the first place. That's 12 times 9 divided by 2 equals 54. Thus, we can conclude that the small plus big triangle's area would equal to the overall triangle's area. How do we see this? Let's add the area of the smaller triangle and the bigger triangle. So that's 30.375 plus 54. It has to be equal to 84.375, which is the overall triangle's area. So that's 30.375 plus 54 is also 84.375, and thus they're the same. So what we want to do next is apply the Pythagorean theorem into a word problem. So Sage School is planning to add some things to the newly released X-ramp in the quadrangle. They need to find the height of one half of the X-ramp without using a ruler. They currently know the length of one half the base and one fourth of the ramp. Given that one fourth the ramp's length is 15 meters and one half of the base's length is 12 meters, find out the overall height of the X-ramp. So to get a better picture, here's a picture of the X-ramp itself in Xavier School. What we want to do is look for Z sides, and currently we know that Z sides are 12 meters and 15 meters. And we have to look for the overall height. In summary, it's this. 15 meters is one fourth the ramp and 12 meters is one half the overall length. And we have to obviously look for for the height of the X ramp. So this is the solution. We're gonna apply a squared plus b squared equals c squared. So that's, we have to substitute the letters, and letter C would be 15 since 15 is the longest side and it's the hypotenuse, which is directly opposite the right angle. So that's a squared plus 12 squared equals 15 squared. Square 12 and 15, you get a squared plus 144 equals 225. Next, you have to look for a squared. Subtract 144 from 225. So that would be equal to a squared. That's 81 equals a squared. What you want to do next is find the square root of 81. So a equals 9. But we're not finished yet. We have to look for the overall height of the X-ramp. This can be achieved through multiplying the answer to the solution by 2, which is 9 times 2 equals 18. So the answer is the overall height of the X-ramp is 18 meters, and we put 18 here and there. So that's the answer. And now, it is up to you. Use the Pythagorean theorem in whatever you think it can be used for. You can also search the internet for more theories about the Pythagorean theorem, and who knows, you might be able to find your own theory and be famous in the future. This is Mark Wang signing out.